The Comptometer, produced by the Felt and Tarrant Manufacturing Company starting in 1887, was the world's first practical key-driven calculator. The mechanism described here is from a Model F Comptometer built around 1915. From the user's perspective, calculation is accomplished by striking keys. The keys in each individual column press down on a lever that extends the length of the keyboard. The keys depress the lever by an amount proportional to their value. The 9 key depresses the furthest, while the 1 key depresses the least. At the free end of the lever is a toothed rack called the column actuator, which rotates a pinion that drives an accumulator gear via a pawl and ratchet mechanism that prevents the accumulator gear from turning during the lever's downward stroke. The accumulator gear only turns during the upward stroke of the lever. The accumulator gear, in turn, drives a numeral wheel that displays the value stored in the accumulator and also drives a carry mechanism described later. The entire gear assembly is prevented from moving at inappropriate times by a locking detent, which is pressed between the wires of a lantern wheel by a stud on the column actuator. When a number key is pressed, the column actuator rotates downward and the spring-loaded locking detent disengages the lantern wheel, allowing the gears to rotate. A backstop pawl also engages the lantern wheel at all times to prevent backward rotation of the gear assembly. The carry mechanism is a very clever piece of engineering. At its heart is the escapement member, a piece of metal with a complex shape. The escapement member is connected to a carry winding gear by a helical spring. Rotation of the winding gear stores energy in the spring because the escapement member is prevented from turning freely by a pair of detents, which are shaped so as to catch a long arm that protrudes from the back of the escapement member. One complete rotation of the accumulator causes the carry winding gear to rotate by half. Therefore, a carry operation needs to be performed each half rotation of the winding gear. The carry operation is triggered by a stud on the face of the winding gear, which pushes the detent currently blocking the escapement member out of the way, allowing the escapement to spin 1/2 of a rotation where it gets caught by the other detent. When the escapement member spins its half rotation, a cam attached to its front momentarily lifts a lever in the next higher column, causing a pawl attached to the lever to advance the lantern wheel ratchet of the next higher order accumulator by 1 numeral space, thereby accomplishing the carry operation. In this sequence, the lower order column 9 key is depressed, followed by the 3 key, which causes a carry. The carry is shown here in slow motion. In the actual machine, the carry takes less than 1/100th of a second. If the higher order accumulator happens to be busy with its own keystroke when the lower order wants to perform a carry operation, the carry is delayed until the higher order accumulator has finished its work. The delay is accomplished by a detaining latch, which is normally lifted out of the way of the escapement member by a stud on the higher order column actuator. When the higher order column actuator is depressed, the detaining latch drops into a position where it will intercept one or the other of the short arms on the escapement member, preventing the escapement member from rotating and accomplishing a carry operation. When the higher order column actuator returns to its resting position, the detaining latch is lifted and the escapement member is free to rotate. In this final sequence, the lower order column 9 key is depressed, followed by the 3 key, which will trigger a carry operation during the 3 keys upward stroke. Meanwhile, a keystroke is also happening in the higher order column, which causes the detaining latch to prevent the carry operation until the upper column keystroke is finished.